Every single day, hackers try to break into servers around the world, and there's one tool standing between them and total chaos. It's called SSH, and in the next few minutes, you're going to understand exactly how it works. Welcome back to the channel. This is where we break down the most important concepts in cybersecurity, AI, and networking, clearly, simply, and without the jargon. If you want to keep your technical edge sharp, make sure you subscribe. Today, we're diving into one of the foundational tools of modern network management, Secure Shell or SSH. SSH is basically a safe, encrypted way to control another computer over the internet. At its core, SSH works like a simple text-based conversation with a remote machine. You type commands, it replies. And just like that, you're managing a system that could be sitting in a data center, across the country, or somewhere in the cloud. The protocol is defined by two main concepts. Shell. This describes a text-based communication method where you type commands to the computer and it provides responses, functioning much like a chat between a human and a machine. Secure. This refers to the protocol's use of encryption, which scrambles messages so that anyone snooping on the network sees only nonsense. The technology behind SSH serves two primary purposes. First is the encryption. Because the internet is not a private place, SSH uses encryption to scramble your messages so that anyone snooping on the network only sees scrambled data or information. Second is the authentication. SSH must prove you are who you say you are before granting access. Using SSH is very simple. You open your terminal, command line, or specialized tools like PuTTY and type something like SSH username at server address. This tells your computer, I want to securely connect to that machine. Before you even log in, your computer and the server agree on the following. First, verify they're talking to the right partner, that is, identity authentication. Second, system will agree on encryption keys. And finally, build a secure tunnel that nobody else can read. This is what protects your data from attackers. There are two common ways SSH handles identity. First, passwords. This is the simplest method, but it carries risks because passwords can be guessed, stolen, or reused. Secondly, SSH keys. This is the preferred method for many teams because it is stronger. It uses a private key, which stays secret on your own machine, and a public key, which is placed on the server. To understand the difference between passwords and keys, imagine a club with a bouncer. Using a password is like telling the bouncer a secret phrase every time you want to enter. In contrast, using an SSH key pair is like having a special ID badge that proves it is real to the bouncer without you ever having to reveal the underlying secret that makes the badge valid. The server runs a test to see if you own the private key matching the public key without you ever having to send the secret itself across the network. Beyond just logging in to manage a server, such as restarting services or reading error logs, SSH is used for several other secure functions. Secure file transfers. Tools like SCP and SFTP operate under the hood of SSH to move files using an encrypted connection. SSH can create a tunnel to wrap other types of network traffic inside its encrypted connection, protecting that data on risky networks. Because servers are constantly targeted by automated login attempts, users often enhance security by using multi-factor authentication or turning off password logins entirely once SSH keys are functional. Ultimately, when someone says they are going to SSH into a server, they simply mean they are going to securely connect to a remote machine to manage it. Thanks for watching. If you want more clear, no-nonsense explanations like this, go ahead and subscribe.